Hello students, today we're going to solve the problem number 19 from chapter 5. So here we have two forces, F1 and F2. In part A they're directed perpendicular to each other. In the part B they're directed at an angle of 60 degree. Now let's draw the picture and see how it's look like. So we have to find in both cases the acceleration and the direction of the acceleration. So let's draw it. So here we have a mass which is m. Then we have here F2 force, and here we have F1 force. Okay, now the mass of the object is equal to 5 kilogram. F1 is equal to 20 Newton. F1 is equal to 20 Newton and F2 is equal to 15 Newton. We know that from the Newton's second law that acceleration is equal sum of the forces or net force divided by the mass, right? Now since we also covered the vector, let's write down in terms of the vector. Okay, now sum of the forces means F1 plus F2 divided by the mass, correct? Now acceleration then is equal, F1 is equal 20 I vector plus F2 is equal to 15 J vector. Okay, the Newton divided mass is 5 kilogram. Now after doing calculation, you can find that your acceleration will be equal to 4I vector plus 3J vector. Now you showed that your acceleration in terms of I and J vector, but however, if you want to find the magnitude of acceleration, then you just have to use the Pythagorean theorem, which means 4 squared plus 3 squared, then you will get 5 meter per second squared. Now how can we find the angle? Now before finding angle, we know that the net force here will be somewhere here, okay, or sum of the forces, or sometimes we just say F net. Okay, now acceleration will be of course in the same direction, so we will have also acceleration which is in the same direction of the force in this case. Now then we have to find the angle of the acceleration, so that means theta is equal to inverse tangent the AY component divided by AX component, which means inverse tangent the Y component here we have 3 divided by 4. Sorry. So that means inverse tangent 3 over 4 will give you almost 37 degrees. Okay, so this angle theta is equal to 37 degree. Now this is a part A. Now let's look at the part B. Now in the part B, we have the mass, then here we have the force 2, then here we have force 1. The angle between them is 60 degree. Okay, now first of all we have to resolve F2 into two components. The one component, Y component of this one, let's say F2Y component, then this will be F2X component. Okay, now let's find that our F2 vector is equal to F2 X component will be cos 60 degree plus F2 sine 60 degree, which is the Y component, correct? So if you plug the numbers, then we can say that our F2 is equal F2 is equal to 15 times cos 60 I vector plus 15 times sine 60 J vector. So f2 vector, then you should get it. The first one is 7 point, the x component or I vector is equal to 7.5 I vector plus 13 j vector, okay, the Newton. Now then finally we have to find the net force, the acceleration. So the net force is equal F1 plus F2, right? Now the F1 is equal to F1 is equal to 20 I vector plus 7.5 I vector plus 13 j vector. So you just have to sum I to I, j to j. So the sum of the force here, you should get that 27.5 I vector plus 13 j vector, okay? It's in Newton. Now finally you just have to find the acceleration. So acceleration is equal to sum of the forces divided by the mass. So here we have 27.5 I vector plus 13 j vector divided by the 5 kilogram, okay? So if you do calculation, you should find that your acceleration will be equal to 27.5 divided by 5.5 I vector plus 13 divided by the 5, 2. Okay, just one moment, it's not working properly, so let's clean up this part. So 2.6 j vector, okay? So after that you just have to use Pythagorean theorem, which is 5.5 squared plus 2.6 squared under the square root. You'll find the value of acceleration, and also you can find the theta in the same way that we found in A part.